All right, today we're going to look at section 3.1, quadratic functions. We've looked at them a little bit in chapter 2, but we're going to go a little more in depth with them. So the first thing we're going to do is look at the graph. So we're used to seeing a quadratic function in the form ax squared plus bx plus c. We're going to look at it at another form also today, but a quadratic function just means we have that squared term. So when we look at the graph of a quadratic function, the graph is a parabola. So when we're going to have one of two types, we're going to have a parabola that opens down, or we're going to have a parabola that opens up. This parabola, the graph, it's symmetric with respect to what we call the axis of symmetry, which is just a dotted line that goes down the middle of the graph. The point where the axis intersects the parabola is called the vertex. You will be asked to find this today. So the vertex is the point HK. It's where the axis and the graph meet. It's either the highest point on your graph or the lowest point. So it's always our maximum or our minimum. We represent it with an ordered pair called HK. So from when we're the graph, you can tell from our function when we had our ax squared plus bx plus c. You can tell if the graph opens up or down by if this a is positive or negative. So if a is less than 0, the graph is going to open down. If a is greater than 0, then our graph is going to open up. So standard form, also known as vertex form, is this for our quadratic function, a times x minus h squared plus k. You still have that a, so you can tell if it opens up or down. Your vertex is hk, so notice your h and your k are from your formula up here. Our axis of symmetry is x equals h. It's just the same as the x value of our vertex. You will be asked to find vertex today. To find x-intercepts, you'll either get them from the graph or you might have to solve the equation ax squared plus bx plus c, set it equal to 0 and solve. And then you'll be asked to find y-intercepts, and here you just let x be 0 everywhere, and then you would solve. So your y-intercept is actually always whatever this c value is out here. So when you are asked to find the vertex and you have vertex form or standard form over here, it's easy. You can look at it and get your hk. If it's in the form that we're used to looking at, ax squared plus bx plus c, now we have to use this formula. So our x, this would be like our x value is just negative b over 2a. Our y value, you plug the x in to get the y, so you're evaluating a function. This is always the maximum or minimum of the graph. Think about when we looked at them when we were drawing them. It was the highest or lowest point, so it's the max or min. So we're going to look at an example using this formula. So we want to find the vertex of the parabola. So the first thing we have to find is the x value. So remember, x is negative b over 2a. So if we substitute in, our b is negative 11, our a is 3. Simplify gives us 11 over 6 for our x value. So now we need our y value, so we're going to plug this back in here everywhere there is an x value to get your y. So we find f of 11 over 6, so I plug 11 over 6 in for x. Work it through in your calculator, and I get 71 over 12. Your final answer needs to be an ordered pair, so it's 11, 6, 71 over 12 for our vertex. So that's if you have to use the formula. We also are going to be finding things by looking at a graph. So here I'm giving you the graph of 2x squared minus 12x plus 10. And we're going to find a bunch of information. So the first thing we're finding is our vertex. Remember, our vertex is the highest or lowest point right here, so our vertex would be 3, negative 8. Our x-intercepts, that's where it crosses the x-axis right here. Make sure you write them as ordered pairs, so 1, 0, and 5, 0. The y-intercept, you can't see it from your graph, but if you remember your y-intercept, if I let x equal 0, these two things go away. You're just left with this 10, so our y-intercept is 0, 10. It's always the constant at the end. When we look at the max or min, which one do I have? This is our lowest point, so I have a minimum. We just want the value. The value is just the y value, so it's of negative 8. This value and your vertex should match. Our domain is negative infinity to infinity, all real numbers. And our range, our lowest point is negative 8, so it goes from negative 8 to infinity. So just getting information from a graph. Let's look at another one of those. Our vertex up here, this time it's our highest point, so it's negative 4, 8, negative 4, 9. X-intercepts where it crosses right here, negative 7 and negative 1, so negative 7, 0 and negative 1, 0. Y-intercept, again, I can't see it from the graph. It's your constant, negative 7 up here, so 0, negative 7. This time our vertex is a highest value, so it's a maximum value, and our y value is 9. Remember, those should match. Domain negative infinity to infinity, that's true for all quadratic functions. And our range, this time it goes from negative infinity to 9, since it's our highest with the brackets. So you will need to get some information from a graph. You're also going to be asked to find minimum and maximum values. So a lot of our applications will do this. So when we do that, we are given our function, and this is how we find our vertex. I gave you that formula previously. So when a is greater than 0, that means I have a minimum at our x value of or is whenever I evaluate it. If our a is less than 0, then we have a maximum value at our vertex. So looking at some examples. So our first one here, negative 2x squared plus 4x minus 5. First we want to determine if it's a max or a min. So in this case, my a is less than 0. If my a is less than 0, I have a maximum. So I know it's going to be a maximum. We have to figure out what the value is. To do that, we first have to figure out our vertex. We need the y value. So first you have to find the x by doing our negative b over 2a. So negative 4 over 2 times negative 2, which would give us 1. To get our actual value now, we plug that 1 back in. I need to find f of 1. So that means if I plug 1 everywhere in here where there's an x, and I work that out, I get negative 3. So I have a maximum value of negative 3. So this part would be our answer. Part B, my a is greater than 0, so I have a minimum. Again, I need to find my x value, so if I plug in negative 4 over 2 times 1 gives us negative 2. Then to get my value, I plug this negative 2 back in here, and f of negative 2 is negative 4, so I have a minimum value of negative 4 right here. So you have some where you have to find equations and find if it's a max or min and what the value is, and then we have some word problems. So here I have a manufacturer has a daily production cost, and it gives us what our cost is. C is our total cost, X is the number of units produced. We want to know how many units should be produced each day to yield a minimum cost. So anytime you're asking for a min or max, that's the vertex. You always have to decide if it's the X or Y value you need. In this case, I'm asking for the number of units, and it tells us right here that X is the number of units. So all I need to do is solve my X equals negative B over 2A to get my answer. So this would be, I have a negative, my b is negative 110, 2, my a is 0.045. Plug it into our calculator, and you would get 1,222.22 units. This is our answer because that's what it was asking for, units. Sometimes they might ask you for the y, so here's an example. If a ball is thrown directly up with a velocity of 40 feet per second, its height is given by the following function. We want to know what the maximum height obtained is. So this time I want height. So this is my y value of my equation, or of my vertex. So first find your x, negative b over 2a. Would give me negative 40 over 2 times negative 16, which is 1.25, but that's not my answer. That would be how much time passed. So now I need to plug that back in here for my t. Solve that, and I would get 25 feet. This is my maximum height, which is what it asked for, maximum height up here. So sometimes it's the x value, sometimes it's the y value. You have to choose. This time it's the y value. Sometimes, like in this one, you will need both. So here, most cars get their best gas mileage when traveling at a relatively modest speed. The gas mileage for a certain new car is modeled, and we're given our function right here. Instead of x, they're using s, and they're just telling us that you're traveling between 15 and 70 miles per hour. So if you get an answer, but that's not in between there, you've done something wrong. S is our speed, m is our miles per gallon. We want to know the car's best gas mileage and what speed. So this time I want the x and the y. So start with the x. I just used s right here because that's what they used in their equation. So our negative b over 2a is 3 times 2 times negative 1 over 28. Plug it into your calculator and you should get 42. I highly recommend you plug this into your calculator and make sure you can get 42. Then for our maximum value, I need to plug this 42 in for s. So everywhere there's an s, I'm going to put my 42. Again, plug it into your calculator and see what you get, which is 32. So then make sure you label what your answer, which is speed, what is gas mileage. So in this case, the car's best gas mileage is 32 miles per gallon when it is traveling 42 miles per hour. So this whole part right here is our answer this time. So if you have questions on anything, let me know. Your assignment is section 3.1 on WebAssign.